Thank you very much, Dr. You appreciate it. Okay, so we're going to, with that, we've wrapped up the introduction of all the panelists, and I want to turn everyone's attention to the shared doc, the link of which is in the chat. And we have a number of questions already. So I posted one as a starter, but I'm going to pick up with some of the others. So we'll get back to the Valley of Death in a second. So the first question here is from David E. The term translation sometimes makes it sound as if one does the research first and then thinks about translating it to an application or production. Is there a relationship about thinking about translation from the start, or a way to link partners from the end of the development pipeline to those that work near the front of it? If that's valuable, are there examples, materials, or other domains where we could use to drive change? Go ahead.
Can I go ahead?
Yes,
Great.
please.
Thank you. I think this is a great question. And I can say that when I first started in my research at the University of Toronto, we would start developing a technology and become quite enamored with that technology, with our heads in the sand and publishing and, all of this. And hadn't thought, in my case, because it's drug development and drug formulations, hadn't thought about whether or not there'd be uptake by clinicians. Hadn't thought about whether or not this would actually be beneficial to patients. And so I think if you really want to translate in a meaningful way, you need to go out to those stakeholders from the beginning. I've got an interesting idea. What do you think about this? And, or even better, what are some unmet medical needs that I could help you with? So I think it's an excellent question that I've learned the hard way. And so really, try to put patients and clinicians first when it comes to translation and design of the technologies we're working on.
Great, thank you. Go ahead,
Oh, I
David.
was just going to say I would echo that 100%. I think in general, yeah, if we can really start to change the mindset of, what is the need, what is the application that's driving the questions, I think that will really help to ensure success. Because again, there's a lot of really good ideas that if you're just looking, like you said, kind of head in the sand, you may not realize, is that actually feasible or viable when it comes to commercialization. So definitely 100% agree that it needs to be the driver in a lot of applications.
Great, thank you. I actually have a quick follow-up to that. And so is there, when you're making these connections with partners that are maybe near the end of the pipeline early on, do you have any advice for how to make sure that you protect IP, especially in the beginning, where you're not necessarily sure if it's going to blossom into a product, but while still gaining useful information that you can use to move forward?
That is a hard question. I guess maybe I'll take a stab at it. I think, to be honest, really the only way that I can think is NDAs, I guess, are your friend. I think really, once you start talking with the company, I mean, you have to be open, because otherwise, if you're kind of talking in circles, it turns out that the connection doesn't really happen. So I think really having an NDA, or at least some level of trust. And again, I know that, and a lot of times in an NDA, you can kind of specify upfront, what is the protected IP, who owns it. And I think you just need to be kind of upfront in those discussions to say, this is our IP, this is where the connections that we can make, what are we kind of keeping, behind closed doors. But again, you just need to be open about it. So it's definitely a hard question. There isn't a, global rule. I think it's just going to be case by case dependent, but that's my take on it.
From my personal experience, I think a good way is to keep recording everything you discuss with your partners, your collaborators. Especially right now, we have really good tools to record all the meetings, right? The autopilot, copilot, ChatGPT can help you to make that recording. So it's easier today.
I'll move to question 3 here. Infrastructure and training seems to be a broadly recognized barrier to broad uptake of machine learning tools for materials design. Is there any agency or organization taking the lead in funding work on overcoming these barriers?
Actually, at NVIDIA, we have a research program, we have university programs. You can apply that programs we support with the computing powers.
And I'd say for any trainees that are in Toronto or in Canada, we've got tremendous programs through the Vector Institute and the Acceleration Consortium, and that will only increase with time. And I expect some will become available virtually as well for folks outside of Canada.
Yeah, I think I would add to what you said. I think automation is probably going to be a big factor. I think in order to kind of really scale these up, we need to be able to translate data, understand it, and even, I guess, curate data. So for instance, knowing what data is important, because we're getting a lot of, if you think about in situ monitoring for some of these manufacturing technologies, we're getting a lot of information, but is it useful? So I think data curation is also a big factor. So again, I think it comes to a lot of data management and then also bridging the length scales. So again, a lot of times we may be looking at smaller scales or just the, FEA scale. We kind of need to know kind of what are the data translations from, atomistic to the macro scale and know what's important. So it is a big challenge, and there's a lot of work that can be done. And I think it's just a matter of tackling those instances.
Go ahead, Dr. Allen.
Yeah, I was going to say that I think comes back to that great question that was asked first around, around translation in general. And I think part of it is when we're doing that basic research, and I agree that not all basic research has to result in product development. And actually some of the basic research that does end up resulting in product development may do so 30, 40, whatever decades from now. And we don't even realize it right now. But we have to also be thinking about like cost of the product, market, competitive landscape, whether or not scale up and manufacturing are feasible. And I think sometimes when we're doing our research and designing these technologies, we don't think about all of these other factors that are so important.
Great. I'm going to follow up for it's a direct question to you, Dr. Allen. In addition to the fear of applying AI ML to formulation of discovery in the pharma companies, do you also face not invented in-house situations? If so, how do you convince big pharma companies to work with you instead of them working internally with their databases?
It's a great question. And I have to say it's early days for our startup. We've only been around for 5-6 months. And I can tell you the approach that we've taken is, we validated our technology and our approach with case studies. So actually designing new formulations of drugs and then comparing them to marketed drug formulations and showing that, how much better they are. So we've actually had to provide that data to give them some degree of confidence in the technology. So that's the first piece. The next piece is that it's got to be collaborative. It has to be kind of like, this is behind the CDA and the agreement. There's got to be a lot of, openness and transparency so they can see what it is that we're doing and it's not a black box. And that they can see that they can contribute to this and they can provide input on what it is that we're doing. So it's not, here's our agreement and we go away and do our own thing and come back in 6 months. It's like, we're working with you and you're part of this.
So we'll go on to Calvin L's question here. This is for Dr. Hicks and other panelists. In your opinion, what is the most important unmet needs that software and AI can make the biggest difference in materials informatics?
Good question. It's a big question. I guess I can give an example of where I think, at least in the context of the work that I do, where I see a big need. And I think a lot of it has to do with verification and validation. So it kind of is that, translation up, but having an understanding of, I make this material, do I have confidence that it's going to work in the application? So for instance, one example is additive manufacturing. It's a relatively, maybe not relatively new, but it's definitely a hot topic. And basically you're building the material and the part at the same time. And so there's a lot of uncertainties that come with that. And then we're essentially trying to get a good understanding of that. And so we're looking at things like in situ monitoring to say, okay, was the process good? And do we expect the material properties that we made kind of on the fly, are they application relevant? And so with that, I guess coming back to your question, there's a lot of data that's being generated. There's a lot of simulation work that can be used to kind of validate that process, because essentially, if you were to make this in the lab, you have to make and break and test, and that's expensive. So if we can supplant these efforts with modeling and simulation, with AI algorithms to basically have confidence in this, then we can start to move the needle a little bit and actually accelerate the manufacturing of these technologies. So that's just one example where I see this being a big, I guess, area of need.
Okay, great. I'm going to go on to Phil K's question. It's got a few pieces here. If a funding agency supported data collection, generation, code development for model development, and software development, what level of government's data rights is appropriate for industry folks to feel comfortable? An example, exclusive data rights for the training data set, at least some rights, copyrights to be held, opening the code, but not the final software package, code and the final software made publicly available. How do we strike the balance between promoting public benefit and the desire to monetize these efforts?
I guess I'll take a stab. This one's a tough one. I think I think it almost depends on kind of the funding agency up front being, defining the requirements. Again, if it is kind of classified work, for instance, it can't necessarily be on GitHub. Alternatively, depending on the contract, you might be able to open up certain functionality or certain data sets. If anything, I feel like a lot of the instances I've seen is the code might be available, but the actual raw data sets may need to be behind closed doors, or maybe that's a little bit more proprietary. So again, that one's a hard one to ask because I think it's really dependent on the application, who the funding agency is. So I don't think there's one answer that kind of fits all the boxes. But that's at least my take on it. I don't know if any of the other panelists have any comments or thoughts.
Okay, thank you. All right, we're gonna pose a Zach T's question here. As AI, ML, autonomous labs become more powerful, can we incorporate recycling processes pathways into the core philosophical definition of materials discovery? I worry we are accelerating the discovery of forever chemicals, materials, waste, etc.
I can just say, I think this is something that we've thought a lot about at the Acceleration Consortium. And, in my own experience in my own lab with the extent to which we've, started to use automation and really miniaturizing some of our processes, we've reduced the quantities of solvents, as an example, that we're using, reduced the quantities of API or drug that we're using. So from a sustainability perspective, it's been great. I do agree, though, this kind of concept, we've talked about this at some of our meetings, this kind of concept of you're just generating a lot of molecules or materials very quickly, and what if they are? So I think we need to constrain some of the or factor that into some of the development that we're doing, and it's a really important point to think about. And it's something that we've started to focus on, and we've developed these core values actually around this, and need to implement those into our consortium. So I think it's an important point to raise.
Fantastic, thank you. We're going to go to Scott M's question. What role have ontologies played in easing the translation problem? Is there any integrated work being done among government, industry, and academia similar to the EU On2Trans project? How might LLMs and AI affect this landscape?
Guess I can take a stab at that one. So I guess with respect to ontologies, I know there's been a lot of work in, I guess, defining ontologies for different manufacturing processes, and also coming up with common data models, common data dictionaries to basically categorize and kind of put these essentially into boxes or classes so that we have an understanding of what is being collected, it's standardized, and it's translatable. So there's also a kind of a data exchange format. So there is a lot of work. I know there's a lot of ontological works in different, probably in the biology space more, so you could probably talk to that, Dr. Allen. But also in the manufacturing space, I know that they're trying to define these ontologies and come up with the schema so that way data is translatable, data is kind of standardized across the domain.
I think interpolation is one of the powerful application of AI, right? So we can start from a small and using the AI power to interpolate everything to increase the scale, increase the scope even.
Great, thank you. And for anyone who's joining, I just want to advertise that we have a shared doc. It's been shared, the link has been put in the chat. If you're interested in posing questions for the panelists, please go ahead and put them in the document and we'll go through them in order. I'm going to answer David E's question. Dr. Allen's response suggests that translating data is a growing part of translating a material. Does industry think in terms of taking certification or validation data directly as a way to accelerate product delivery? Is there much organized discussion about this in industry? David Hicks spoke to this by listing validation and verification and additive manufacturing. As it happens, this is a central topic in a new NASA STRI called IMQ-CAM, working on metal additive manufacturing digital twin, or any comments thereof.
Oh, I think you might be on mute, Dr. Allen. Did you say anything?
I was going to say maybe you have a comment on that.
Sure. Yeah. So yeah, I guess I'm glad that you brought up the NASA STRI. Maybe I'm not familiar with that exact work, but actually, some of the work that LIFT has been kind of looking at is actually a NASA document that tried to put together what would a V&V look like for materials qualification in the context of modeling and simulation. And so that's something that we've been looking at LIFT, is how can we kind of participate in that effort. So I do think that is a big drive in industry, at least in some of the working groups that LIFT has been a part of, is, again, going back to that common data model. There's an additive manufacturing common data model that's really trying to also engage in that effort. So that way we know what data to collect, what are the important data elements, and how can that used to certify these manufacturing processes. So I do think that there is a big drive, and I do think there are quite a few different organizations who are tackling this. And I want to say that the Air Force is also looking at one. I forget the name of it. But there is a lot of drive and effort into that. And so it's kind of a multi-pronged approach where this group is working on it, this group is working on it. So it's definitely a hot topic for sure.
Great. Okay, I'm going to go to Jane G's question, which is a follow-up to Scott's question. Would anyone be able to suggest some good steps for material science communities to better connect or embrace ontology work that's been done, or is there a disconnect or not invented attitude that keeps communities from adopting already developed ontology schemas, etc.? So I think the heart of the question is really in standardization. What's the opinion of standardization of some of these ontologies?
Again, I guess I can take a stab at that one. Relates to kind of the previous discussion, but I do think there's a lot of communities out there that I think you can be involved with. I think NIST is, for instance, leading some of those efforts to define those ontologies. And I do think that they're trying to kind of keep it collated, obviously open. They're open to working with groups. But I think they're also trying to make sure that there aren't multiple standards. And so I think they are trying to get a lot of people involved, so that way there's consensus to say, okay, these are the important data elements. This is how they should be defined. So I do think there's a lot of work there. And I mean, there are probably some, siloed endeavors, but again, I think really to kind of push the needle here, we do need to kind of get involved with those groups that are already actively working on it, so we can kind of make a change there.
It's interesting. We've heard today a couple times this kind of concept of not invented here, and it's unfortunate that that is reality, right? We're faced with that, and there's a lot of siloing. And yet, in my field, anyways, during COVID, we just saw this tremendous interest in collaboration, like not just in a specific area of research, but many areas of research and across countries. And I think this comes down to, as scientists, we have to commit to advancement of the field. And in my case, in the area that I work in, we have to center patients. And if we do that, then that means that whole kind of not invented here should go to the wayside, at least for government and academic organizations.
Fantastic. Go to Calvin L's question. While new solutions are really exciting, how much effort do you think we should make in investing in existing solutions? Currently, some solutions like SRIM feel outdated, crash often, requires a Windows environment, but is a popular tool for simulating ion beams into materials.
I think it's really hard to predict which technology will be the final successful one, right? So, like in the AI area, initially we are enthusiastic about the CNN convolutional neural network. Then we found the transformer, and we also have RNN. Right now, the transformer is a star in the language model, but we still seeing a difficulty to process videos, images, data, right? So it's really hard to make a decision at early stage.
Great. Yeah. I have a question it tags on to some of the questions we've already addressed. So it's a two-parter. So what are the challenges uniquely addressed in industry, and then what roles do you see academia and national labs playing in terms of addressing these challenges?
I guess maybe I'll take one stab at it. So I guess at least from the context of what can academia and national labs do, I do think that there's a lot of, I guess there's a big knowledge base there, right? So for instance, the industry kind of knows the application, but I think a lot of the technical experts getting into the detail comes from academia and national labs. And so I think essentially academia and national labs could essentially serve as the intellectual powerhouse, if you will. And I think they can really help to, when they know the industry knows the challenge, but they may not know how to solve it. So I really think they might be able to help drive the innovation because they have the know-how, they know the skills. And I mean, ML and AI is, everybody's talking about it and it's a big thing, but a lot of people don't necessarily know how to use it effectively. And especially, in the leadership communities of the industry, they just know ML and AI, they've seen it, but they don't know how to use it. And so I think kind of grounding it, but then also having the expertise from these labs and academia, I think they might be able to play a big role here.
I think the academia national labs is more like a pool of technologies. So we in industry we do not know which one will be tomorrow's superstar, right? When the new superstars shows up, we probably do not have enough intelligent technicians to achieve that. But at this time, the national labs, the academia can provide human intelligence powers for that.
I think in some cases also academia can de-risk some of this, right? Like prove it out, demonstrate that it works and should be adopted by industry maybe at larger scale.
Great. I have a question. I'm sure that there are many people who may have an idea or maybe even have a proof of concept of that idea. Do you have any advice for how to best approach an industry partner on an idea, on a pitch? I'm sure you've seen it many times, but what's really stood out in your experience that's made the pitch more successful, made your ear come closer to the idea? What do you think is good advice for that?
I can maybe start. One of the things that I would say when I'm pitching something to a company is I do some research on the company, and the pitch is really tailored to that company or that audience. So I look to see, what is the company doing? I try to think about what their problems might be, how I could help to solve those problems. So if it's a technology that I've developed or a formulation or whatever it might be, I can see how that fits into their narrative or their story. So I don't have one pitch that I use for all companies, all audiences. It's really a tailored approach. And
Yeah.
I try to go in with a soft sell, I would say.
Yeah, I think each company they have different preference. It's really hard to have a uniform method to approaching all the companies. And for NVIDIA, our CEO is very powerful and has insight about the development of technology. Just look out what he speaks.
We have a new question here from again, the spirit of MLAI, the MLAI approach to discover new materials is a hands-off approach, whereas each specific piece of material discovery requires arbitrary depth of understanding. How do you balance the two there?
That's a good question. Because yeah, I know that there's a lot of AI ML approach for like it mentions in the question, materials discovery. But once you've found the material, knowing kind of what are the different facets of that material. So again, I think it goes to a little bit more into, I guess, maybe the next step in the process. So you found the material. How do you synthesize the material? How do you manufacture the material? And that's going to change the properties depending on how it's made. So I think it's taking a more in-depth, almost a different faceted approach to, okay, now I have the material. What do I need to do with it? So for instance, again, that goes back to manufacturing. For instance, you can go ahead and check to see, if you actually make it, you can actually do these in situ monitorings and, check to see what are the data outputs, and you can use ML and AI there to confirm or use data to kind of basically say, what are the properties based on this ensemble approach of, printing a whole bunch of things or manufacturing in different ways. So I think it's just a different way of looking at it. But yes, definitely an important aspect for sure.
Okay, great. I'm curious, what do you think was the biggest step of the transition between going from academia to industry? What was the big change there in your thought process about this problem of materials discovery, how you think about AI, about algorithms? What was the biggest change in your thought process that you saw when you transitioned to industry?
I guess I'll start. I think really it was the shift in mindset of, I guess, fundamental research to applied. I think, it probably is, it seems, trivial, but I think the gravity of it is just a completely different mindset. And I think that was just, again, I think it's a good mindset, like both have merit, but I think that seems to be the biggest transition for me is, I'd love to continue, keep doing fundamental research of, okay, how can I look at this? But the company's not going to necessarily pay me or, say, hey, you can't look at this. So I think that's been the biggest challenge for me. But again, it's an interesting challenge because it does focus more on manufacturability, synthesizability, which again is a problem that I think still needs tackling.
For my personal experience, I think when I doing my PhD, we have limited resource, so we focus on what we can do, what we can deliver. But in industry, I think the mindset changed to what we can collaborate in. So you have a bunch of people sitting over there, and how do we together to achieve a something huge, right? That's
Great. Let's see. Okay, so we have a new question from Matt E. Following from Dr. Akel's point about humbleness, how best should companies interact with the academic publishing environment? With the exposure they would get either way, do they really need to publish closed papers in Nature and Science with press releases and non-peer-reviewed marketing, or is that the company's desired deliverable? In my opinion, there is a danger that the current approach is too discouraging and demoralizing for academic researchers if it seems that scale can solve all problems in the field. Maybe it can.
My personal take, I think, might be similar. I'm delighted to see papers coming out of industry. Any data, results, whatever that they'll share, whether they're positive or negative, I'm always delighted to see. And I didn't really quite speak to that on my slide around challenges, but one of the challenges that we have in the drug space or drug development space is that there is a lot of data in industry that we'll never see. right? And so the more that we can see that data and the results, the better off I think we all are. And I don't necessarily think they're always better papers, but they're important papers as well.
Great. I think I'm going to wrap up with one last question. And it's focused on those that are interested in maybe making a transition to industry. What data skills are needed to be successful, and are there any recommendations to gain these skills?
Yeah, I agree 100%. It's the soft skills, communication skills, interpersonal skills, ability to collaborate and work in a team. We have super bright people in academia, super bright people in industry. And I think what really helps people get ahead are these soft skills, or get noticed or succeed even just in an interview are these soft skills.
Yeah, I guess echo both. Yeah, definitely communication, and I think, but also being able to communicate, I guess, broadly, but then also scientifically and technically, because you're going to be working with both in industry. You're going to be working with kind of the boots to the ground people, but then you're also going to need to communicate it to leadership. So it's multifaceted in that sense, but yeah, definitely communication.
I want to go to a little more detailed bit about the communication skill. It's not only talk to people's more useful things is you are be clear about what you need to do and be clear about what they're going to do. So make that record, write it down is always much helpful.
Great. And with that, we're right about at time. So I'm going to ask that we see if we can get the link for the next session, which is the repository session. We should see that come up in the chat. I just want to wrap up by thanking the panelists, Dr. Allen, Dr. Hicks, Dr. Yu, and Dr. Akel. If you have any comments to add, I leave the floor open for a minute or two. Please feel free to chime in. Any final comments?
I was just going to say to all the young people that are here today, and there seem to be some trainees based on the questions that were asked, I just think this is a super exciting time. I wish I was young. I'm not that young anymore, but super exciting time for all of you.
Agreed.
Yeah. Go ahead.
Oh, no, I was just going to say, yeah, agree. And I think regardless of what path you choose, I don't think there's a wrong path. I think academia, national lab, industry, I think there's a lot of work that can be done with respect to data algorithms. So I think you're in a good spot. You're in the right field, and the world is your oyster, essentially. So yeah, you guys are going to do great, and good luck. And yeah, I envy you.
I would say maybe academia industry has different goal, different driven. However, the skills, the knowledges you learn are going to be help you both either in industry or academia.
Fantastic. Well, with that, I'm going to just wrap up and say the Google Doc's going to remain live for 2 more weeks if people want to continue to add thoughts or ideas. The next session began a minute ago, but the link is there for that session. And with that, we thank the panelists and everyone for their time. Thank you very much. This is a very, very nice discussion.
Thanks,
Thank you
everyone.
very much.
Thank you. Bye.
Bye.